So something we can do with stoichiometry is percent yield. So it's a calculation we can do after you do a stoichiometry problem and calculate how much you should be able to make based on how much you started with. Then you can calculate a percent yield after you do a reaction, the same reaction, in the lab setting to see how close or how well you did. So it's kind of like your grade or your score. Because what you'll do is you'll take how much you got when you did the experiment, divide it by how much you should have got when you did your calculations, and take some differences in there and figure out a percentage, do some calculations. So percent yield is something we can use to look at how efficient and effective we are when we're doing these specific things in the lab setting. So percent yield indicates the percent of theoretical yield, that's what you should have gotten in an experiment, and what you actually got in the experiment. So obviously the closer to 100% the better. 100% would mean you aced it. You got exactly what you calculated you should have gotten. 100% is not really ever attainable unless you're a very, very good chemist in a very, very controlled setting with extra particular and special and exact measurements. The percent yield calculation, the formula we use is percent yield. You do your actual mass, what you got in the actual experiment when you did it, and divide it by your theoretical mass. So remember, theory is like something that in theory it should be this way, something that should happen. So that's how you can remember your theoretical mass is what you should have gotten when you did all your calculations. You know you should have gotten this much. So you do your actual mass, what you actually got in the lab experiment, divided by your theoretical mass, which should have been formed from the given, using stoichiometry to find that. And then you take that answer times 100 because it's a percent. Your answer will be labeled with a percent, and that's your percent yield. Then you can rate them as excellent, fair, and poor. So if I were taking my cooking example again, if 2 sticks of butter, 4 cups of flour, and 3 tablespoons of sugar should make 2 dozen cookies, that would be my theoretical mass. It should make 2 dozen cookies. But when I do the recipe, I found out I actually only make 22 cookies, which is less than 2 dozen, less than 24. I can figure out my percent error. So my theoretical would be I have 24 cookies. My actual mass would be the 22 cookies I made. So I would do 22 divided by 24, what I should have gotten by my recipe. Take that times 100, and I get 91.67% yield. So I'd label it 91.67% yield. And then I would rate that as excellent, fair, or poor. Excellent, we will say, is anything 90% and above. Like excellent, you better be really good. It's a little bit like kind of like a college grading scale A. Excellent, 90% or above. So I would rate my 91.67% yield as excellent yield. Fair will be anything 50% to 90%. So anything that's above, you got more than half, like it made at least more than half of what you should have made. That would be fair. Anything all the way up to 90. And then poor will be anything 49% and below. So anything you guys can figure out or write that down somewhere so you can remember. Your excellent is 90% and above, fair 50 to 90%, and poor anything below 50%. So the other thing we can do with percent yield is we have percent error. So it's kind of the opposite. It's how far away you were. So what we do is that you take the difference between your theoretical value and your actual value. So the percent error, you do the actual mass minus theoretical mass. So remember, the actual mass is what you get in your experiment, minus what you should have gotten based on your stoichiometry calculations, minus your theoretical mass. So you would do that first. Then you would take that divided by your theoretical mass and times 100. So this will get you a lower number. And so obviously with this one, the closer to 0, the better, because that means you messed up the least. That's your percent error. How far off are you? Or you can calculate percent error because your percent error is the difference between 100% and your percent yield. So if you really just want to memorize that percent yield is actual mass divided by theoretical mass times 100, and then you can find your percent error from there, instead of memorizing 2 different equations. So if you get like a 91.67, I would do 100 minus 91.67%, and I would get 8.33%. So that's like for my cookie example. So my percent error for my cookie example, I'm 8.33% away from being perfect. So the percent error is pretty much how far away you are from the 100%.